record. All right, and here we go. Hi, everyone. Welcome so much. Welcome to our demo day. We are so excited to have you all here. We know that it has been a whole process, this invention journey of all of you really putting in your dedication, your hard work, your creativity, your ingenuity, and this beautiful empathy piece into your projects as you created for social good. You developed these prototypes and inventions to really help out your community. And today we are so excited to be able to showcase all of you, the hard work that you've done, the wonderful thoughts, the wonderful projects, and also be able to see the impact that you're making. So yes, I'm Carrie. I'm going to be your MC today for Demo Day. I'm with Project Invent. Again, our teams, as you're joining, if you could please make sure to rename yourself, your team name, so that way when it's time for us to play your videos, to really show all the wonderful work that you do, and you get to talk to our judges, we'll be able to spotlight you pretty quickly. All right, and with that, let's get started. So here's our schedule. We have 9 teams joining us today. This is the run of show, and we have an awesome keynote speaker that's going to join us in a little bit later after the pitches, who's going to be talking about technology, his personal experience, and tell us a little bit more about invention, innovation, and impact. So we also want to say a huge thank you to our sponsor for today, Sequoia. We truly appreciate all the support that allows us to make this happen. And while we're getting started, if you want to drop into chat where you're coming from, that would be awesome. I'm calling from New York. So right now, before we get started, if everybody could just say hi and put where they're joining in chat. We got Santa Clara. I'm calling from New York City, Colorado, Pennsylvania. We got East Coast, West Coast, Washington, D.C., Washington, Chicago. I love it. Phoenix, Arizona. Oh, we are all over the place today. And I love that during these demo days, we all get to come together and celebrate our teams and really build this community even more. So we also encourage during this event, utilize the chat. If you have questions, if you want to show support and give feedback to a team that's presenting, absolutely please utilize this chat, especially during virtual events. This is a great way for us to interact with each other. All right, so let's continue. We all know Project Invent. We empower students with future-ready skills to succeed individually and impact globally through invention. And what we all are trying to do together, you all are doing an amazing job, is we want to create that generation of fearless and compassionate problem solvers. So without further ado.
Hi, I'm Samhita.
My name is Maximilian Chavez.
My name is Carmelita Lee.
Our product for today is for children with autism because they find it extremely hard to identify their emotions and cope with stress.
We created the Beta Band, which is essentially a headband. It reads your beta waves, which fall in between a certain low and high beta wave. And if you're outside that range, then your brain is not acting as a normal brain.
Project Event has definitely impacted my sense of teamwork. I can collaborate a lot more with my peers, have that design thinking into mind. How can we target our users and have the best influence and the greatest impact on their lives?
Working and coding and doing all that stuff, it gave me a chance to be familiar so that I'm not as intimidated going into college. And it's actually made me a lot more excited for freshman year of college.
We've definitely opened our minds up a lot more, and we've learned how to cope with maybe our product not working and still learning from our mistakes.
Having interacted with people who are on the spectrum, young adults and little children, and seeing what they go through and understanding their experiences, and then being able to put that into a product, engineer something, and then see that truly affect them and help them.
A lot of people try and create products for people that they don't even they've never even talked to before. So we had a lot of things that we thought would be good, but after talking to people who actually use wheelchairs, they were we don't have problems with that. So it just you really should talk to people and get to know them before you make assumptions about things that they struggle with.
I think the impact has been huge, and it's changed my outlook towards education for project-based learning and education a lot, actually. The reason is because prior to Project Invent, I focused a lot on just developing technical skills and having the students learn laser cutting, 3D printing, soldering, sort of for the sake of learning 3D printing, laser cutting, and soldering. But working with Project Invent and anchoring these technical skills to a real world problem has really, I think, made the learning experiences more meaningful for the students so that they understand what the application is and has helped with retention and student involvement. It's been really great.
None of these girls came into this project thinking that they were inventors or makers or that this kind of thing was something they even wanted to do. All of them, I believe, have been radically transformed just by this idea that the world is invented, right, and designed, and that they can participate in designing that world, right? I watched them gain confidence interviewing people, really understanding and delving into design thinking and human-centered design. I watched them struggle through prototyping and then succeed and feel really empowered by that. We have 4 women here who are ready to take on the world and change the world with the invention that they're making. And this is not something that they would have even considered doing like in September of this year.
It's been really amazing, like being able to turn a problem into a solution just through engineering. And so I think like Project Invent has taught me that anything that you see out in the world, if you think there's a way that you can fix it, it's totally doable, and that there are resources out there and people out there willing to support you throughout the journey.
This is bigger than just us.
All right. Now, before we actually get into the pitches, I love that video because it really showcases the work that you all are doing. And I see, yes, so many beautiful minds and this creativity. I love that and totally agree. So if you feel comfortable, please turn on those cameras because I want to give everybody like virtual high fives. I want you all to look at each other because this is an amazing community. You all have done the work. You have really been creative. You have put your heart, your minds into this. So cheers to all of you. Congratulations. And yeah, are we ready to get started? Let's see this excitement. There we go. Awesome. Perfect. So now I have the pleasure of introducing some really awesome professionals who are joining us today as our panel of judges, and they're going to listen to your pitches, and you then are going to get a quick Q&A with them. They're going to ask you any other questions that they have about your product and your project, and it's a really awesome time for you to be able to interact with them. So, without further ado, Armando unfortunately could not make it today, but I would first like to introduce Shalvi. Then we have Shanawaz and Tony and Deborah. So we'll start with Shalvi. I'm so curious, what are you excited about today to hear from the students, to see? Tell us why you're excited about Demo Day.
I think it really just makes me interested to know how the young minds are thinking. And so when I came across just the idea of Project Invent and eventually all the students in their maker spaces, they kind of put in 1 year of hard work, create something meaningful, and then demo it in front of the judges. I thought the entire activity is so meaningful and just exciting for the audience, especially because I'm sure that they're all coming out with amazing ideas. So I think that was the reason to join on the judging panel. But in no way I'm thinking of it as something that I'll be deciding in terms of like awards or winners. I think everybody just by participating in this is a winner in themselves. And so I'm just here to see what exciting things everyone's created.
Oh, I love that. And I agree. Even though we have these awards, every single team has made such an impact already. And getting to this point to be able to present at Demo Day, totally agree. Awesome. So we're going to move on to Shanawaz. What are you excited about for Demo Day? What you looking forward to hearing and seeing?
Yeah, hi guys. This is my third Project Invent judging event. So in every time I come, I feel like, okay, the person who's learning out of this event is me. And I go out, getting so many ideas, and I see the way these kids are putting the critical thinking and the design thinking into their projects and for the social cause. So that helps me to, come back each time and, work with them and see their work, which excites me. And when I go back to my work, I can, take some ideas from them. And even eventually, I'm a product innovation manager. I can put some of those thoughts in my implementations in my workplace. So, I don't come as a judge to get the things out of or figure it out the winner. As somebody said rightly, like everybody who's participating is a winner itself in these particular demo days. So it's pretty exciting to see how the collaboration and uh, the skills to influence each other without getting into the confrontation comes up in these demo days. So I really love those collaborations and the design thinking skills of the kids coming up, and I wanted to contribute and see if I can do a little bit of my piece in that. So that's something which is very exciting for me.
Oh, I love that. And yeah, we're so excited to have you back again, being part of the Project Event community.
Yeah.
All right. Thank you for sharing. And Tony. Hi, Tony. How's it going?
Good. Thanks for having me here today. I'm really excited to hear everybody's presentations. This is only my second time with a project event day, and I'm already very inspired and motivated by what I've seen, and just adding to what the other two judges said. All of you truly are winners already. You're here, you're showing up, you're putting yourself out there, and I'm really looking forward to this. Thanks.
Awesome. And last but certainly not least, hi, Deborah.
Hi, everyone. I mean, the other judges said it so beautifully. It's not much that I can really add, but I think overall, I'm really excited about just seeing all of the hard work that you guys have put in over the past few weeks and months and seeing like the accumulation of that and like that final output. It's always super interesting to just see all of the creative and unique ideas that you're working on. And this is just the beginning process of that, right? I think some people are going to take these ideas and really work on it, or maybe this is just like the building ground for future ideas in the future. But I think either way, it's just always really inspiring to see what people are working on and how you're trying to create products to really impact the world. So I'm really excited for that.
Yes, yes, and yes. Awesome. Thanks so much for sharing. Great. So our judges, they're going to be watching the pitches and doing the Q&A with you all. And we want to shout out our teams. So we have 49ers STEM Leadership Institute, Board Makerspace, and Best Buy Clues here today. So I want to shout out not only the teams who we're going to see in just a few moments, but also our fellows. So right now, we want to thank Tracy and Jack and Chris and Juan and Victoria, because you all have gone through Project Invent. You have brought this to your learners. So we want to shout you all out. We see all of the work that you've done before, during, and after all this. So here's to you all too. Great. Now I can get us started. We are first going to have Team TimberTech. So transform any cabinet into precision kiln, portable, reliable, and built to protect your wood from cracking while drying.
Hello, we are Team TimberTech. Aaron, Adwaita, Anishka, Silas, and Ethan.
Meet Ray Hari, a woodworking teacher in the Santa Clara Unified School District. He teaches high school students and adults and is passionate about working with the lathe. But Mr. Hari faces a major problem: wood cracking. When wood dries too quickly, the outer layers shrink faster than the inner ones. This stress causes cracks, ruining projects and wasting valuable material. Large industrial solutions like wood kilns are expensive and too big for classrooms. Mr. Hari needed something compact, cost-effective, and easy to use within his space and budget. As Mr. Hari told us, a problem we face is making sure that before we use it, there aren't as many cracks.
This issue goes beyond the classroom. Independent woodworkers, artisans, and small workshops often face the same challenge. These communities deserve a low-cost solution that works.
That is why we created TimberDry, a compatible adjustable drying sleeve. It wraps around the ends of wood and uses heating pads, cooling fans, and sensors to gradually release internal moisture. It mimics the function of a kiln, but at a fraction of the size and cost, just $60 per unit. It's adaptable, easy to use, and ideal for small spaces. In our first prototype, we used neoprene fabric, heating pads, sensors, and a 3D printed mounting plate. It worked, but lacked a humidifier and cost around $100. During our meeting with Mr. Harvey, we showed him our first iteration. He stated, with sleeves permanently connected to the device, it makes it hard to dry with large quantities of wood at the same time.
Here are our components for iteration 1. We have a 3D printed mounting plate, a humidity and temperature sensor, an LCD display, a neoprene fabric sleeve, a cooling fan, and a heating pad.
In iteration 2, we added a humidifier. We redesigned the setup to be placed inside a cabinet or container to create a kiln-like environment and reduced the cost to just $50, making it even more effective and accessible.
Here are our components for iteration 2. We have a 3D printed mounting plate, a humidity and temperature sensor, an LCD display, a humidifier, a cooling fan, and a heating pad.
When comparing both iterations, iteration 2 is cheaper, more compact, and simulates a kiln-like environment more accurately, thanks to better humidity control and layout flexibility.
Full-size wood kilns cost around $5,000. Wood sealers are cheaper, but don't actually prevent cracking. TimberTech bridges that gap, offering a reusable, efficient, and affordable tool for anyone working with wood. Looking forward, we plan to automate fan speed based on temperature, improve heating and airflow performance, and tidy up wire management for safety and ease of use.
Thank you so much for listening, and we are very excited to show a product that supports makers, cuts down on cost, and keeps craftsmanship alive.
Awesome job. All right, so judges, take it away. What questions, comments do you have for TimberTech?
I guess I can go first. So, great job, I think, to the team for even thinking of it as a problem. I think it was very new for me to even learn that this problem exists. So, definitely a great job just finding out something so unique and then trying to solve it. A question I had through just looking at the process or your iterations was that uh, the problem that you're trying to solve for the wood cracking, is it happening before the wood goes and becomes a furniture piece, or is it after it's already become a furniture piece and so the furniture can also crack, or the wood in while being created as a furniture can also crack? So is it the initial problem that you're solving, like right when the wood is chopped off from the tree, or is it the later part of the process?
Okay, yeah, great question. So the problem that we're solving, the wood cracking, actually occurs before it's turned into furniture or whatever they decide to do with it. It's during the drying process, which happens before anything else can happen because they need to remove all the moisture from the wood before they can turn it into any projects.
Got it. Yeah, that's helpful. And then the second question is that I saw the device that you kind of created, especially the second iteration with the humidifier. Would that device be attached to every log piece? For example, like a small workstation or a small studio would have, let's say, 10 log pieces. So would you have to create 10 units and attach it to each log for the process to happen?
That was just so the mechanism itself is basically our product, and you basically put that mechanism, which is like the blue like 3D printed plate, you'll put it into any enclosed area or cabinet, and it'll turn that into a kiln-like environment. But we also have a sleeve attachment where you could purchase separately, and with that you could apply you could put it on the two faces of the wood for it to dry.
Okay, got it. Thanks.
TimberTech, hi, this is Tony. Very creative, very creative. And you know what? I have a brother-in-law who is a professional carpenter, so he's going to love to hear about this. I just have two questions for you. Can you share maybe a little bit of research that you did about the need or the industry for this? You know, like, are you going after professional carpenters, or would this be for like your amateur artisan doing this at home? That's my first question. And my second question would be, what could you say about maybe safety or fire safety? Only because when I hear the word kiln, I think of high heat and fire. Could you speak a bit to those two questions, please?
Okay, so to answer your first question, you were asking about our intended audience of the product, right? So this is not targeted so much to professionals, but more so people who, like our community partner, are working at a school in like a small area, or people who do it for fun, just as a hobby on the side. So people like this can't afford to spend thousands of dollars on a kiln, nor do they have the space to store one. So our product aims to close that gap. So it's more so for non-professionals.
And then your other question about fire hazards was, there's a difference between there's two types of kilns, and ours is more of a wood drying kiln. They have other kilns for like pottery when you're trying to put it in the clay, but ours is controlling the temperature, so we control like the humidity, the airflow, and like the heat going into it, so that it keeps a stable environment, so that the water doesn't flow out too quickly, it doesn't dry too quickly, so that there isn't cracks in the wood.
Thank you.
We have time for like one more question from our judges.
Hi, Timber Tech. Awesome presentation. Similarly to what Shavi said, haven't really thought about all of the considerations relating to wood, so this was really cool to hear. I was curious about learning a little bit more about kind of like your design process, and so maybe like why do you make certain decisions in terms of like your final product, one, but then also two, like how long would it take to dry the wood? Once so if someone's using it, would it take such a long time compared to like the other alternatives you mentioned, like the wood ceiling?
So for our design, we really wanted a compact design, as our community partner mentioned how there's not much space in his woodworking classroom. And for the drying time, it should take around the similar time, like for a wood to dry inside a kiln, as our device simulates a kiln-like environment. So that's maybe 2 to 3 weeks.
Yeah, thank you.
Great job, Timber Tech. Awesome. And now we're going to move on to our next group, Team Keith, who has created a smart cart.
Hello, we are Team Key, a team dedicated to creating technological solutions to real-world problems. Our team is comprised of 3 sophomores and 3 freshmen, with me, Rishi, Ani, Ryan, Alyssa, Anya, and Rahul. Our community partner is our school's culinary teacher, Chef Keith, who helped give us feedback throughout our design process. Chef Keith's problems include being busy throughout the day, giving him less time to spend with his wife, and encountering difficulties with rushed dishes due to limited class time. We finally decided upon our smart cart as a solution to Chef Keith's problems. Our design includes trays to hold ingredients and mechanism wheels to give our cart 360-degree movement. We tailored our design for the classroom using Arduino ultrasonic distance sensors to ensure it doesn't bump into obstacles. The Arduino, which is connected to the breadboard, contains an ultrasonic sensor which is designed to navigate the room it is delivering ingredients in, as well as ensure that it does not run into walls or objects in its pathway. The breadboard is then connected to a battery pack as well as the mechanism wheels carrying the cart.
Competitor matrix. A struggle that we had while creating this product was differentiating it from other products on the market. Through our research, we did find that Similar products are used by restaurants to deliver food to tables and customers instead of waiters. Smart Cart is differentiated as it is tailored to a classroom setting to be used by teachers and students to save time and deliver materials. We plan on using the dimensions of the classroom based on the setup, which is different for all rooms, which will be decided by the teacher. In the image below, you can see the culinary classroom at Santa Clara High School where this will be implemented.
Our next steps to advance Smart Cart are to test its endurance with different materials on its racks to determine the weight it can carry. We plan on finding the most efficient routes to navigate the culinary classroom to save as much time as possible. Redesigning it out of wood and connecting it to the other set of back wheels will result in higher endurance and smoother transportation. That's all for our pitch. Thank you for listening.
Nicely done, Team Keith. All right, it's time for your Q&A with our lovely judges.
Hey, Team Keith. Great job designing like a cart which is on wheels. I personally did not have the time to understand the problem because the slide kind of went too fast. So can anybody just explain a little bit more to everyone present that what was exactly the problem that you were solving for Chef Keith? Because I could understand what he does, but I did not really follow the problem statement.
Okay, so for Chef Keith, he said when we interviewed him, he said a lot of his problems were kind of time management in the classroom. So basically, when students walked into class, they generally had a lab, which is generally like cooking something, but then it took them several interactions to deliver ingredients. And because like you know how kids like clump up in like big groups to collect ingredients, and the teacher has to like help them organize and like get all the ingredients in order to actually have a successful lab. That takes a long time. And additionally, he has to keep going around and checking to make sure students are doing it correctly in order to make sure nothing goes wrong in the kitchen. And because he spends so much time managing the students and managing like the ingredients and making sure nothing goes wrong, because culinary is like kind of a more dangerous, subject in general, it also means that he has significantly less time to actually like grade and like keep track of like students like scores and attendance and stuff like that.
Got it. So like when you guys were thinking of like the problem statement and how to solution for it, the iteration that we saw was the cart, which was on wheels, and so you prototyped it like that. Were there other ideas that came to your mind while thinking of the problem? Like what were other things that you thought that would solve for his problem?
We thought of a couple other potential ways to make attendance and grading easier for him. So one of our earlier ideas was making like a button or like a scanner that could help him like just like press the button and then like manage attendance or like scan the student's ID card to like mark them down or like make sure students have proper like attendance and like dress code and stuff like that. But we settled on a smart card in the end.
Got it. Anybody else wants to chime in from your group about the other idea?
One of our prior ideas, like Ryan mentioned, was a button. So that was more of a button that would have an audio recorder to have him, because he explained that he was a very forgetful person. So it was more made to help him remember like who was absent, who was tardy, because he explained that having to go back and forth in the classroom would take away time from the lab. And since the labs are done during the school day, you have a set block of time. But we found that it would be unviable, especially with the scanner, because we would have to create an entire barcoding system in order for that to work. So we decided on reducing or not focusing on that problem and allowing him to just have more time to focus on his students and his classroom without having to deal with the tedious like tasks like delivering ingredients that he could have already pre-portioned and set out on the cart to deliver.
Got it. Thanks for sharing.
We have a few more minutes, so would any of our other judges have any questions?
Team Keith, wonderful job. I have a quick question. Can you say a little something about why you selected the size of the cart that you did? Because that's something that could be if it's too large, it could get in the way, or if it's too small, then you can't add a lot in there. Can you say a little something about why you decided on the dimensions that you did?
Yeah, so for our dimensions of the cart, it was really that his classroom was very cluttered since he has individual kitchen sets for all of his students. He has around 10 kitchen sets, and in the middle, he has a group of tables. So it's really difficult just to even like walk around the classroom since there's so much things and there's chairs and there'll be students moving around. So we looked for like a smaller module for them to do it, and we even looked for ways to minimize movement and turning of the cart, which is why we decided on mechanism wheels, which allowed it to shift instead of turn.
All right, great. Thank you so much, Team Keith. Nicely done. Okay, so we are going to be moving on to our third group that will be presenting today, the humidified cabinet, which is a cabinet to keep your woodworking wood moisture balanced and climate controlled.
Hello, we are the Wood Turners, a project and vent team in Santa Clara High School.
Our mission is to help non-industrial woodworkers keep their community recycled wood in good condition.
This is our community partner, Mr. Hari. He's a teacher at Santa Clara High School, and he loves to do woodworking projects with the students. His main issue is that the wood that he often uses for these projects cracks during the drying process due to lack of moisture.
This is a quote from Mr. Hari during our first interview. This quote helped us give the main inspiration for the idea of the humidified cabinet. In this quote, he explains the phenomenon of wood cracking and how cracks are created due to slight amount of stress. This helped us realize what the main problem was and gave us the main idea for the humidified cabinet.
After a lot of thinking and iterating, we came up with a solution to make a cabinet that can store wood and regulate the humidity. This way, the wood won't be able to dry and crack. Mr. Hari was very interested in this idea. During our first interview, he said, "I'm interested in the idea because I want to see an idea that captures a sense of protecting wood from cracking." On the left of the slide, we can see that in the beginning of our iterative process, we made some CAD models to visualize our product.
Before starting our actual project, we demonstrated our project on a software called Tinkercad. And even though we weren't able to find the actual sensors we were using, we were still able to learn a lot of our code. We were able to access data, process it, and then display it on our screen. And using this software, we were able to skip a lot of our iterative process because we could see our changes in real time.
Here are some features of our product. Our product can control the humidity of the cabinet, has compact spaces for different types of wood, and it has cooling fans to reset humidity. Our two inputs are two sensors, a humidity and a temperature sensor, which affect our outputs, a humidifier in case humidity levels get too low, Arduino fans to help reset the humidity, and a power relay module. This is another quote that Mr. Hari said during our second interview after explaining our idea and our sketch. This quote helped us redirect our testing process as he explained his satisfaction for the idea, but he wanted us to start testing in a way where we only use one log and then we could troubleshoot any problems before we change or expand it.
So this is a comparison to the top selling humidity cabinet on Amazon. So the pros of the first one is that it's big and compact, it has high accuracy and humidity control, it's going to be durable and safe, and it's also noiseless. The cons are that it's expensive and it's not specifically tailored towards wood, and it's very complex for a user to use. Our project, however, the pros are that it's tailored towards all types of wood. It has a very simple user interface, so the customer would be able to use it very easily. And it's cheap but durable. The cons are that it is small, it is not noiseless, and not as much accuracy as the top seller. And the dimensions are 8 by 6 by 12, while the exterior dimensions of the top seller would be 12.6 by 11.4 by 16.5.
Our project has come pretty far since when we started, but there are still things that we need to do. Some of our next steps are to perfect our circuit, make our box out of wood and acrylic, and incorporate some testing. Next up, we have an interview with our community partner.
Hi, my name is Hari, and I teach wood turning here And we work with wood a lot. So one of the problems we face is green wood, when we cut it from a tree and bring it in, because of different factors, they start to crack. And so we are trying to figure out a way to prevent cracking in wood.
So this is our solution. It's a cabinet that modifies the humidity in the inside so that the wood is at the right humidity for it, which is approximately 45%. So as you can see here, we have a screen. We have a screen that shows the temperature, the humidity of inside the box, and then it also shows our fans, whether they're on or off.
And in this scenario, you can see that the humidity is greater than 45 degrees. And since the humidity is greater than 45 degrees, the fans turn on to lower the humidity, just like how a vacuum would.
And then this is not happening right now, but if the humidity is too high, there's a humidifier inside.
Too high or too low?
Sorry, if the humidity is too low, the humidifier would turn on and that would increase the moisture inside the cabinet so that the wood would not crack, basically.
So really great design. I really love what you guys have done. Okay. Especially the way you can put 4 fans, which could probably potentially control the speed of air movement by controlling how many fans operate at the same time, right? And that adds a lot of, what do you call it? Different ways you can control the humidity. And product something like this, there are a lot of wood turners out there who would love to have something like this. You could consider keeping track of the data. Okay?
Yeah, so thank you so much.
Thank you so much. You guys have done a fantastic job.
All right, thank you.
We really enjoyed working on this project, Mr. Hart. We didn't get to put the full interview on our video, but if you want to look at it, here's a QR code.
Thanks for including that QR code too. Would be really interested in seeing that whole video.
Thank you so much. Thank you. Does anyone have any questions about our project?
Yeah, well, awesome job. This was really good. And yeah, loved the interview and the fact that you guys were really great with getting that client like feedback and making changes based off of that. I think that was really, really cool. I'm curious about like we saw your one product model, but were there other designs or maybe considerations that you were thinking of? Were there any like obstacles maybe you encountered as you were working on your like product iteration?
So originally we had planned to make a bunch of different shelves in our cabinet, each one at a different humidity regulation, because each piece of wood comes from a different place with a different humidity. And if we can get the cabinet to the right humidity for the piece of wood, then it wouldn't crack. So first we were thinking we'd have a big cabinet with different shelves that each have a different humidity. But then we found that making a prototype of that would be a little hard. So we decided to make it a little simpler and we tried it on cardboard first. Um, which it worked. And then we actually have one of our next steps here, which we made the cabinet out of acrylic and wood so that the humidity doesn't affect the components that the cabinet is made out of.
Really cool.
Yeah.
Well, team, I would say that it's a good team effort you guys have put. And I wanted to know that are there any learnings from the failures and the iteration you have done previously while going through these projects?
I would say one thing that we learned is definitely not to push certain tasks off until the very end, because towards the end of our project where we already had an iteration and our circuit was working really well, it would keep breaking because we put off like wire management to the very end. And so we had to figure that out after it was too complicated to to manage efficiently. So one thing that I would definitely say I took away from this is to not push away the smaller tasks before they become bigger problems. So.
Okay, that's good. And the other thing what I loved about your presentation is that your comparison with a product which has already been established in the market on Amazon. So that's something which I really liked it, and the way you have presented the pros and cons. So work on your cons, and make sure that your product is more competitive within the product which is in the market. And all the best to you guys. You have done a good job.
Thank
you.
If there's still time, I had one tiny question. So, team, if you had to realistically think about um, wood turners having all sorts of woods and wood types in their studio, like let's say a wood turner has 10 different types of wood in their studio and has to store all of those in different conditions. I know that your cabinet does provide customization around humidity and temperature, so anybody can do that. But would I have to build 10 cabinets for those 10 different types of wood, or would there be a little bit of a compilation of some sort of a solution where if I have to store all 10 different types of wood, I can do it within the same cabinet or within the same space? Maybe it doesn't even have to be an enclosed space. Like, how would I really do that?
I guess it's like mostly on the user side to kind of understand, what are like the ranges or what are the values of humidity that wood dries best at. And like you have different types of wood like oak, maple, and they're kind of like in similar areas where they grow at. And that also means that they also dry in the same ranges of humidity. So what our product offers is that we, instead of having like one set value of humidity to like, go up or go down, we have a set range, and that offers a lot of versatility in terms of the types of wood they're using. And if you do have um in case you have like different types of wood, you can have like a set range that the user has tested from, and it allows you to store those multiple types of wood inside the cabinet.
Yeah, and just to add on to that, the same way that we had our first iteration that was a smaller version of our product with cardboard, we have like this acrylic version of our product, and this is still like a scaled down version. So when we make it bigger, there'll obviously be more room to hold wood, and so we'll just be able to group the different types of woods that are very similar. And if you said in the same area, not exactly in the same cabinet, I'm assuming that there could probably just be like maybe 3 or 4 of them to encompass most of the types of woods that the wood turners would need for their purposes. So
Sounds good. Thanks, guys.
Awesome. Nicely done, wood turners. Congratulations. I love seeing all these projects. Amazing. All right. So we are going to move on to our next group, Team White Salmon, with their trash detector, the device that detects trash in public libraries and alerts staff.
Trash detector. Our team consists of Ada, Kat, and Miles. Our community partner and a problem she has. Holly is a librarian who consistently has to clean up after others who leave their trash after reading or using the library's computers. Our solution. Our team, with some input from the library staff, has come up with the idea of a trash detector. The trash detector would be able to detect the trash with or without a person. If the trash is with a person, then the detection is silent. But when trash is left and there is no person with it, the detector will notify the library. We currently have a prototype of our project that looks like this. In this video, when the person walks in, the Raspberry Pi connected to the camera highlights the movement in green boxes. However, it cannot detect whether the person or the trash is different things, and it When the person gets up and leaves, it also doesn't know that the trash is left behind, and it doesn't know to send a notification to the person because it can only detect things that move. This is what we want our end result to look like. In this video, it also highlights the person and the trash as they put down their stuff. And it doesn't send an alert to the librarian because it knows the person is there. Then when the person gets up and leaves and it realizes the trash is left behind without the person, then it highlights it in red and sends a notification to the librarian. Our product's features. Our camera uses a program developed in Python to detect whether objects in a specific area is accompanied with a person or not. The camera will take a picture of the location it is pointed near. If there's a change in the photo, it will make a box around that object. If there's a person with that object, the box around the objects will be green. But as soon as the person leaves and is no longer in the frame, the box will turn red. To the left is an example of what would happen with the person detected. User testing. We tested the code with the camera in our local makerspace. We were able to detect a change from one image to another and create green boxes around the changed objects. We took the camera to our library and showed our community partner. She said the idea was cool and she looked forward to seeing what we ended up creating. The camera was taken to the library again to make sure the prototype worked in a new environment. Although these are good first steps, we know there is a lot more that we need to put into this project to make it something that the library can actually use. Competitor matrix. The only thing close to what our final product will achieve are security cameras. Security cameras can detect the change in an image and notify someone just like what we want to do. The difference between our product and security cameras is that our camera does not send a notification if there's a person also in the view of the camera. This makes our product a new and special design. Next steps. To advance our product, we mainly need to make the camera able to differentiate people from other objects with specialized code, find a way to notify the librarian when the object is not with a person, have a follow-up with the librarian to ensure our product is on the right track of what the library wants. Thank you for your time, and if you have any questions, you can ask them now.
Interesting. I have a question. So suppose if I'm sitting in a library and I'm having a, a glass or a mug of water and some a packet of chips um, and a small piece of paper and a pen. And I was sitting there for like 30 minutes. I thought of, okay, I need one more book. I left my stuff there and go and, try to grab a book. And I'm coming back in 5 minutes back. So what is the lead time of you becoming that box is getting read and sending that notification to the librarian, even though the person is still around? How does that work?
So proposing we would have, say, a timer so it knows that if the person is just getting up and using the bathroom or not, so it doesn't just immediately alert the librarian if there is nobody in the picture.
So that's what it's a good step, but we don't have that quite yet. So that is a very interesting question that we need to address. Currently, it would notify right away because if say the person leaves, we want the librarian to immediately be able to say, "Can you please pick up your trash?" But yes, so our camera would not know if they're going to the bathroom or not. So that's a very interesting question.
Okay, because end of the day, if somebody wants, like the librarian will not be able to run around, right, in each notifications. So suppose a library closes at 6 p.m. In the evening. If there's a collaborated or there's a single alert system, like he gets a report that there is a stuff lying there, these are the places and all those things, then it could be much easier, right? Rather than he getting up, maybe multiple alerts is good, and his attention will also be diverted, right? Like if he gets some multiple alerts, he must have some other work also. So if he gets an alert altogether consolidated saying that these are the corners of the decks of the library where you have stuff lying without any person around it, or whether the without the owner of that person. And then end of the day, he like within 15 minutes of closing of the library, they can go and grab all those things and put it in lost and found. If something has to be trashed, they can put it in the trash. So your prototype is different, but like you need to think about it how to make it more viable and are usable for the librarian. Thank
Yeah.
you, but yeah, good.
Oops, sorry, I was going to say, following off that question, and I guess first prefacing, great job with the presentation. I think it's always important to keep your libraries clean, so that everyone can have a great experience. I was curious on two fronts. I think first of all, you talked a lot about like, notifying the librarians. But I would imagine like as people coming to the library, sometimes you don't know when you like, forgot something behind or forgot to throw things away. Have you considered maybe the people who go to these libraries and like finding some way to notify them? Or did you do any like surveys, like thinking about like, like based on like how often people may leave things behind? Did you speak to like actual like library attenders or people who like visit libraries to kind of see how they would feel too about being tracked, or having a camera on them?
No, we haven't talked with any library patrons about the system so far. Only the library manager.
Hmm. Yeah, because I would imagine that maybe, I mean, there's some security concerns, but which would be important to consider. But then also for those patrons, maybe they might want to have a notification and it might be easier than, always notifying the librarian. Um, I was also wondering too, have you maybe thought about other use cases for this product too, like outside of the library? Because I think this could be really applicable to a lot of different like use cases.
Yes, we have. We've thought about using the program that can detect things in other cases, such as finding animals or other things in a different environment for recreational purposes, maybe.
Very cool, super cool. Thank you.
Team, great job with the presentation. I was just wondering that when you guys decided to code the objects into the camera, or like the way you designed the code, what is the reason behind coding the human also as an object? Because I saw that when the objects were identified, the human was also kind of identified as an object. So was there a reason that you didn't keep the human as just a human and everything else as an object, included the human as an object?
Well, in our like final thing, we want the Raspberry Pi to like know that the human is a human. But when we were trying to show what our thing can do right now, and it can't tell the difference between a human and like a trash bag. So yeah, but in our final like thing, we would want the human to be known as a human and a trash bag to know.
Got it. Thanks.
Great. Thank you so much, Team White Salmon. We really appreciate all the hard work and thought that you put into your project. We are going to continue onward and we are going to move forward with Power Patrol, a secure and accessible way for students to easily get power to their devices while also keeping users accountable and chargers traceable.
Our Power Patrol, and this is our Project Invent Demo Day pitch. I'm Cassian.
I'm Kat. I'm Celine.
I'm Tristan, and Saharsh couldn't make it today.
Our community partner is Mr. Wilson, our Santa Clara High School librarian. He really enjoys his job as well as helping others. His main problem is borrowed Chromebook chargers not being returned. He wants students to be held accountable if they lose one.
The idea we came up with to solve this problem is an automatic charger locking system, and we're excited about this because Mr. Wilson has expressed a large need for more student accountability when donating chargers and Chromebooks. And this is a audio clip that expresses that.
But we have like in weeks past, we'll give out 25 chargers and we'll get 10 back. We want to have, of course, these be readily available for students because it helps students out. But at the same time, we need students to be accountable for the assets that they're taking from the library.
When we were brainstorming, we wanted to have individual chambers for each charger, and each student would type in their ID onto a small keypad located next to the chamber, which would release a charger that they could use, say, for a day and then return it. We also wanted the student IDs to be sent to Mr. Wilson so he knows exactly who has a charger at what time.
So we decided to settle on a modular charger locking system, and to unlock a charger, a student ID would need to be inputted, which would then be sent to a spreadsheet so Mr. Wilson can track and view the students that currently have chargers and hold them accountable. So this is some of the software that we have, and so the first image on the top left corner is a Tinkercad code simulation that basically let us run through our code without actually having our components first, and it made it easier for us to test our progress. And the second images are just code to send data to Google Sheets. And this is more code for the actual physical Arduino. This is the stuff we imported into our project.
As for the hardware, this is the build we have right now. You can see from the top view that we have our main board along with two breadboards, one which isn't currently in use and the other one is connected to the LCD. We also have our small servo which isn't currently hooked up, and our keypad, which is where the students will input their student ID.
So a few weeks ago, we weren't quite ready yet, but we are ready now and plan to show our community partner next week for feedback. Some existing solutions we had thought about with our community partner was a tracking barcode scanning system and a repurposed phone locker, but for chargers.
So we've made a competitor matrix that details the affordability, feasibility, and student accountability of all three of these products that we thought of. So for our idea, the automatic charger locking system, it may be slightly difficult to implement. It's quite affordable and it holds students accountable very well due to how it retains their student IDs. The same goes for the affordability and student accountability of the barcode scanning system, except that one is actually pretty difficult to implement. In fact, it's probably impossible to implement because it's very hard to integrate new barcode systems into the existing one that the school already has. And as for the repurposed phone locker, while the feasibility and student accountability are both not that good, it also is very expensive to put in place, which makes it an overall worse idea than the other two. Code that we have in our Arduino. And so we have our LCD here with the keypad. You can type in numbers and then reset the code. And then you have to type in 6 digits or else it won't let you enter. And once you type in 6 digits, the servo will spin and then it'll wait a certain amount of time to let the student take the charger out and then it'll lock itself again. And this is the back. That's the Arduino we're using.
We'll be sending the IDs to, so here's the, the student email, so Mr. Wilson can copy paste. And this is how, oh my God, what? And there we go, and it logged the student email, and as you can see, there's a new input in here with a student email, the timestamp, and the date. And this updates the most recent one.
Great. All right, judges, take it away.
Hey team, great job thinking about the losing chargers. I feel like even in college, we had a media room where people would just borrow devices and chargers, and we thankfully had a system in place so nobody could just take it away. I was wondering that at the end of the prototype, you kind of showed how the email is going to be automatically updated as soon as the student takes the charger or puts it back. The ones who are kind of taking the chargers home and then are given a week or 2 weeks time to kind of hold on to it. Is there a reminder system that you were thinking of putting in place? Or is that not something that is part of your solution?
Wait, are we unmuted?
Yeah.
So, the reminder system is part of the spreadsheet where because the student ID gets logged into the spreadsheet, Mr. Wilson, like we have conditional formatting on the spreadsheet that like flags whether or not the charger has been returned within the last 24 hours. And if it hasn't been, then he can either choose to have the spreadsheet send an automatic email to the to the student who has checked out the charger, or he can like send his own follow-up emails on his own.
Got it. Thanks.
Hi, team. This is Tony. Very well done. I especially liked your competitor matrix. That was well done. Could you say a little something about how far down each road you went before you decided that's a dead end and we don't want to do that? You know, when you talk about the repurposed, the different items, can you just say a little bit about, you know, how far you went with each of those different avenues before you turned around?
Yeah. So for the idea of having the barcodes, we mentioned the idea to Mr. Wilson during the interview, and that's when he told us about how they already have an integrated system that he doesn't like. Mr. Wilson can't actively add things to it, and it's like the company above, like that gives them the books that already pre-adds the barcodes. So we wouldn't be able to put barcodes on them ourselves. And as for the phone locker, without these, the phone lockers would probably be pretty, we wouldn't really know how to get them. And if plus, the student accountability part is probably the worst part of it, which is what really made us think that we shouldn't do that. Because it's kind of, it doesn't really retain this, the student IDs in any way. As not like the barcode scanner, which you could use a student ID for.
Thank you.
Hi team. You guys did a great job. Yes, I think definitely it's funny because it reminds me of a problem like when you lend a friend your cell phone charger and then you never get it back. So I feel like if I can give accountability to my friends, that would be awesome. I would love to kind of just learn a little bit more about maybe any problems or challenges that you faced as you were doing your prototyping, or maybe any lessons that you learned along the way that kind of impacted your decisions.
Yeah, so one major problem that we actually had was during our prototyping stage, our initial idea for our box was just a box that had a lid that would open straight up or open behind it. And the problem with this is because of how big Chromebook chargers naturally are, they take almost 4 to 8 inches of space, which means that Mr. Wilson would almost need a setup that has at least 16 inches in width. And that was not feasible for Mr. Wilson at the time. So to combat this, we made a box that actually had a lid that folded inside it using about 1 millimeter thick plastic and gear racks on the top. This way the box folded into itself and it only took the space in which the box itself accomplished.
Great. Thank you all so much. Again, very, very relatable. I feel like a lot of us are looking at this like, oh yeah, that charger sharing issue. Awesome. So we are going to move on to our next team from Best Buy Teen Tech Center, Clues, with Plush Pals, a plushie that brings happiness and good memories through recorded words.
Hello everyone. We're excited to introduce you to our project, Plush Pal. This is more than just a plush toy. It's something created to bring comfort, support, and connection to an often overlooked group, elderly people dealing with dementia or Alzheimer's. Our table of context, it consists of our team, who is your community partner, and our product. And now I'll be introducing our team. First, me, which is Adnan, Mohammed Amin, Valentine, Emiliano, Amanda, Estrella, and Oscar.
So, who's our community partner? Our community partner is Monica. She works at Clues in the Community and Health Department as a health educator. Monica plans events and offers resources for seniors, especially those with dementia. But recently, the budget cuts have been making it harder for her to offer those surfaces consistently. That's where we want to help. The challenges we face. Many of the seniors experience deep loneliness, especially those with memory loss. Monica shared that when events are cut, it leaves these folks with fewer opportunities for mental and social stimuli. And as we know, activities that engage the mind can actually slow the progress of dementia. Our product, Plush Pal, is what we want to make the difference. I got a question for you guys. What is the first emotion or feeling that comes to mind when you think about the plush you had during the early years of your life? Still, if you have it, no judgment at all. I'll give you guys 7 seconds to answer. All right, 7 seconds has gone. If you said happy, I would agree with you. If you said bad, I don't know what to say. Maybe you'll find a better choice in the future. Better place. Okay. Our intent of the project is to bring happy, good memories back. That's all we intend, to bring good memories, mental stimulus, and mental activity back to the mind so you could slow down the progress of dementia. That is the main focus of our project.
This isn't just a this isn't just a toy. This It's a simple but powerful tool. Inside PlushPal is an Arduino board that powers a DF player mini MP3 module and a speaker. With a push of a button, it plays calming sounds or memory training messages. These sounds are meant to stimulate the mind and bring emotional support. For the price, we kept this project affordable. The Arduino Uno costs $27.60. The DF Player Mini MP3 costs $5.90. The speaker costs $7.99. So did the button. Total, just under $50. That's cheaper than many store-bought plush toys, and those don't offer memory support.
So what's next? We're already thinking ahead. Some of the future features include more voice lines and languages, a recording option for custom messaging, movement features for the plush pal to move around, maybe hug your hand in a sense, and a mobile app to manage the settings. Maybe add your voices from there, maybe choose how it moves, something of that sort. We want to keep improving. We want to just stay stagnant. We want to change. We want to improve, make it better, make it, while also keeping it close to the same price range.
What makes us different? Compared to options like Build-A-Bear, PlushPal offers more purpose. Ours isn't just cuddly, it's smart. It helps with memory, promotes emotional well-being, and still brings comfort. It's a meaningful, thoughtful product without the extra cost.
Thank you for listening, guys. This will be the end of our presentation.
Have a good one.
Bye. Hey, hello, we wanted to give a live demo.
Hey.
We couldn't record it in time.
Yeah, we would love to see that demo.
Yeah, so it's very simple. So you have a button at the nose where you can just press it in order to let out the sounds. And I'll press it right now. And our main audience is people that speak Spanish, and most of the elders speak Spanish. But we also have some English speakers. So we had 2 different languages currently. So it's English and Spanish. So Spanish is up first.
Está bien bajar el ritmo y recuperar el aliento. Ya has enfrentado situaciones difíciles y has salido fortalecido. Este no es el final, solo un capítulo difícil de tu historia.
And next up is English.
Está bien bajar el ritmo. It's okay to slow down and catch your breath. You've faced hard things before and come out stronger. This isn't the end, just a tough chapter in your story.
That's pretty much demo.
It's a good one. Yeah, the novelty of your product is good. Whenever it comes to helping elders or people with Demnitia, those kind of products really will stand out in all the hackathons or in any of the projects. So it's good. Just a question, the app which you have developed, who's going to manage that app?
The app that we have dedicated, we were expecting to use an MIT app inventor, and we were going to implement a Bluetooth into the Arduino, and with an Android device, you could send messages just as easily as just recording a message, and it's going to come in.
Yeah.
And it's reassuring for the elder to know there's always someone there, even if the family member can't make it. So it's manageable by anybody, honestly.
Anybody? Okay, not the seniors.
Yeah.
Okay.
Hi, team. This is Tony. Very well done. Could you say just a little bit more about the process to get to this point? Maybe some of the conversation or the back and forth that you had with the community partner. When you were making suggestions to them, did they say, "Oh, this won't work, but maybe this will work"? Can you speak a little bit more to that about, maybe what didn't work or what how you chose to end up with your final product there?
Yeah, so in the beginning, we asked a couple of questions to Monica. She said one of our biggest things are they're lonely. The elders are lonely. They don't have any company. And what I want is for them to know that they're reassured that they have people that care for them. And so our thought was, why don't we give them something that could give them a little bit of love and maybe support? And the main role of the app we wanted to make is so that their family could put in words of affirmation so they could keep hearing it and repeat whenever they want, whenever they feel down. So that could help them throughout their day.
Thank you.
No problem.
Hey, team, I had a question about some of the text that you had on your presentation slides. So I think in a few places it said that this plush pal is supposed to help support memory,
Yeah.
and also had a few lines around how it's going to bring back nostalgia and give comfort and all of those things. Um, did you, during your research with the elders, kind of find out that comfort, warmth, nostalgia, all of these things kind of mean different things to different people? And so maybe a plush pal does not bring out those emotions in the elders, or was it the other way around?
For the elders, we had one of our teammates named Oscar kind of go to a meeting, and he asked them, "Hey, what is the best way for you guys to remember your family by or bring comfort?" He said, "We want to hold something, we want to hug something that we could carry around, something that's portable." And the first thought was, "Hey, a plush, something that's huggable, something that you could store anything within." And the main problem we had was how big to keep it and how small. So we brought different sizes from this big to something this big, and this is what they chose. And they kind of chose a Shiba Inu dog. So yeah.
And then how does your pal kind of support memory?
Um, Many of them forget sometimes that they have a certain family member. So with like the voice coming in constant, like, "Hey, hello, this is Adnan," for example, kind of must remember because if they had like a play date with a family member, the family member could not make it. And it's like, "Hey, you can remember me by this voice." So
Got it. Thank you.
thank you.
So much, Plush Pals. Nicely done. Great. All right. We have three more groups that we're going to be showcasing in this part of our demo day. So without further ado, we are going to meet the Mints, stopping fires at the first spark.
Hello, we're the Mints, and our product is called the Emberi, which is a self-automated device that identifies fires and precisely extinguishes it using a motorized targeting system. Before we introduce our community partner, we'd like to introduce our team. My name's Angeline, there's Aiden, Karosh, Saharsh, Kevin, and Gabrielle.
This is Miss Mint, the curator of the Brian Osborne Nature Center at Peterson Middle School. Her job is to make sure the plants and animals are all functioning as part of an ecosystem, along with cleanups now and then so that the students at the middle school can come for a tour every few weeks.
When we met Miss Mint, we got to know her and the Nature Center. We noticed a problem that was originally overlooked, and it was all about one shrub. In response to that problem, Miss Mint said, "I can see it happen if I do not control the biomass removal or soil moisture content in that area as a preventative measure." You may be wondering what that problem is. That problem is called shrubal fires. They are essentially highly flammable shrubs due to the saps that they produce. With recent climate change, plants dry more, causing more natural fires. The reason why that's a problem is because of the location of the Nature Center, which is within a middle school.
Our solution is the Ember Eye, which is an autonomous device that uses CV and IR sensors to detect fires and extinguish the start of the fire. The difference from this and normal fire extinguishing methods is that the Ember Eye detects and kills the start of the fire instead of waiting for the fire to grow and then detecting the smoke. This is our demo video.
These are the projected numbers for our final product. The overall cost of Ember Eye would be $200, the extinguishing radius would be around 6 feet, and the amount of time it would take for Ember to identify and trigger would be 4 seconds.
Our first input is an infrared sensor, and this will continue on running until it picks up an abnormal amount of infrared, which is usually fire. From there, our device will pinpoint this location and move horizontally and vertically to line it up with the extinguisher. Our computer vision program will run to double check that it is a fire, and if it is, it will shoot and extinguish it.
Once the CV program is started, a stream of the camera data is created. Then, our custom trained model is run on the camera data to find detections. Once the positions of those detections are found, we move the winch and turret to center the fire in the frame. Then, the fire extinguisher is triggered. This is a complete software flowchart. As you can see, it starts with a fire being detected by the IR sensors. Then, the CV program runs, and once it doesn't detect a fire anymore, the program terminates.
So this was our build process. Everything we made started from computer-aided design on Fusion 360, so that we can visualize everything before we made it in real life. Our first phase was completely 3D printed, and it was all for the mechanical movement. We were able to position our model fire extinguisher in any position in a 3D space. We did this by elevating our platform using rails that were pulled up using a string pulley, and we were able to turn a turntable around using 2 gears. Our second phase is the phase that we are currently in. We're integrating all our electronics onto our product and scaling everything up and still by keeping in 3D prints. We have motorized movement and a Raspberry Pi as the brains, which takes an input from IR sensors and a camera to position our spray can at any matches to put them out. Our third phase is where we plan to upscale completely. We'll be using all wooden structure, eco-friendly fire extinguishers, and a pulley with a larger gear ratio. Along the way, we faced many struggles, and these are the ones that stood out to us. In our first iteration, we struggled with our pulley as we were pulling from one side of the platform, creating imbalance, and we had difficulty raising the platform. We fixed this by using 2 strings on one pulley going to 2 sides of the platform to maintain balance. In our second iteration, we found that we couldn't spray low as our sprayer was mounted above all the electronics. To combat this, we flipped our entire thing upside down and had our spray can below the platform while all our electronics were above.
Upon showing Miss Mint the first early stages of our product, Ember Eye, she liked the idea of an IR system and saying any type of early notification for a sign of fire is very valuable, as spreading an active burning area is expected to be fast moving due to dry plant biomass, which is why we started to emphasize on how the fire will be identified with using a CV and an IR system.
So Ember Eye had 2 main competitors. The first one was the Skyfi Labs robot kit, and as it is a kit, you have to have your own hardware, software, and the knowledge in order to build it. The second one is the indoor inspection firefighting robot, and it is very similar to ours, but it is better for indoor environments. Ember Eye, though, is more suitable for outdoor environments like Miss Mint's Nature Center, and because it isn't a big or chunky robot, it will not scare the fauna or damage the surrounding flora. If we had more time in Project Invent, we would want to do 4 things. First thing would be to increase the size in case of bigger fires, but we would want to keep the weight balanced. The second thing we would do is to find a more eco-friendly extinguisher fluid that stays within our budget and does not negatively infect the environment. The third thing we want to do is to share with the community so we can help other people. Examples of this include local gardens, other nature centers, and national parks. The last thing that we would want to do is to enter third phase because we were very, very ambitious with this project and we would want to finalize our second phase and move on to the third one. Thank you so much for listening. Do you have any questions?
Thanks so much, the Mints.
Good prototyping. I wanted to understand that where are you planning to deploy this product? Are you saying that you're going to deploy it in the open fields where you have shrubs which are more likely to get fire?
There's a specific area in Miss Mint's Nature Center where it's about 15 by 15 feet. a specific type of plant that is really prone to being on fire. So we plan to put one there so that if there were to be one, we would be able to extinguish it.
Okay. Okay. And like you said that it is only able to detect 21 inch of the fire within 21 inch, something like that. If I catch it correctly.
Yeah, so just to clarify, this is a small scale prototype, and that meant that our electronics were scaled down as well in order to be, more affordable because it's only a prototype. However, when we do scale up to the full model that can extinguish up to 6 feet away, we will scale up and use more sensitive IR sensors to detect fires from up to 6 feet away.
Okay. And then will your future product will have the capabilities of moving like a robot, like the other two prototypes you were showing, the the one which you're comparing with?
No, our product is not meant to move over like a large area. It's meant for like a small area that you see that could be like very flammable. So just like our prototype, there'll be a central pole, and our fire extinguisher will be able to move around it to cover like a 3D space around that pole.
Okay. Oh, okay. Thank you so much.
Hi, Mintz. Could you please say a little bit about Miss Mint's feedback for you on this project? Since you've been in communication with her, as you build this, can you say a little bit about what she's said to you, about what works or what doesn't work?
So,
sorry, you could go.
So every iteration we made, we were constantly in contact with Miss Mint with emails and photos. So she was able to give her own input so we could personalize it for her and the area she was looking to keep safe.
Great, thank you.
Hi, Mints. Great job with this presentation. Maybe I missed it, but could you kind of describe a little bit more about like how you detect what you're going to extinguish? Because, for example, you have the candle, and so let's say it's like I'm lighting a candle and it detects it. I don't want it to be extinguished, but how do you make that determining factor? Especially if the main goal here is to prevent like the fires happening before the fires have even started.
So basically our goal is to detect like really any fire or any sign of a fire. So that could be a cigarette butt on the ground or, like a small spark. Anything in this area can instantly cause a fire. And since it's inside a middle school, that could be super dangerous. So our goal is basically to have like a temporary solution. So only during fire season, they could take it out and plant it in the ground. And in that area, whenever there's like a small spark or something that's on fire, it would just extinguish it, preventing any chance of a fire happening.
It can all be also a case that you can deploy that in the gas stations also. It's a small area, right? Nearby, near the pump where you pick up the pump and start filling up the gas. Think about those use cases where you can, within your lab and within your school, you're gonna deploy that. But that is also a use case. Like sometimes people become really, really very careless and they are in stress and something, then they light up a bud and sitting in the car, and then the smoke starts coming out and there's a chances of, things getting up. Uh, and there are a lot of incidents also happen in past. So your product is a very good candidate of the deployment in these areas as well. So I think you should think about that also out of the box thinking.
Okay, thank you. That was a really good perspective.
Thank you so much, the Mints. Great job, great job. All right, we have two more teams left, and we are going to introduce the librarians. So a Chromebook distribution locker that keeps the Chromebook secure while not in use and tracks students' Chromebook checkouts.
Hello, we're the librarians, and this is our team. So our community partner is Mr. Wilson, the librarian at our school, Santa Clara High School. And two of the main issues that he has is with students not returning the Chromebooks or Chromebook chargers that they borrow from the library. We decided to focus on the issue with students not returning loaner Chromebooks on time. To combat this issue, we decided to make a design that did not take any more of Mr. Wilson's time, since he had several meetings every single day, fit into the library environment so that it would not look out of place, and improve students' returning probability so that Mr. Wilson did not have to track them down manually. To show you how much of an issue this has begun to cause Mr. Wilson, we have a quote from one of our meetings with him, where he said, "This has become kind of an issue, maintaining this fleet. We have 25 working loaner Chromebooks, and on Monday we had 16 that were gone. This shows that within the span of one school day, they had already lost 64% of their loaner Chromebooks that they have working."
This is what's currently being used in our school library. On the left, there is a paper sheet where students note down their student ID and are given a loaner Chromebook from the Chromebook charging port. At the end of the school day, they are expected to return them.
Our original design contained three main components: the outer shell, the charging base, and the keypad screen system. The outer shell would be made up of wood for stability and would contain all the Chromebooks and circuitry. The charging base would be the one Mr. Wilson already utilizes, so we can save on cost and maintain some familiarity with the product. Finally, the keypad screen system would allow students to input their ID number to receive a verification email to access the Chromebooks by turning the motors to open the doors. After running the original design by Mr. Wilson, he provided us with some feedback. Some key points and adjustments he wanted us to make were to utilize Chromebook charging cords instead of using the charging base to charge the Chromebooks, prioritizing self-sufficiency so students may use a Chromebook kiosk independently, gearing the Chromebook kiosks to provide short-term loaner Chromebooks instead of long-term loaner Chromebooks, and to make a printed list instead of emailing the students so that Mr. Wilson can address the students himself. Using the feedback Mr. Wilson gave us, we adjusted our CAD design of the product. Firstly, we added dividers to replace the dividers that were in the formerly used charging base. Secondly, we downsized the design to hold Chromebooks without cases, as the shorter-term loaner Chromebooks do not have cases. Lastly, we added holes for individual chargers to the bottom of the design. Additionally, in the future, we'd like to modify the design to contain a more accessible backing for our pairs and staff's needs.
This is our circuit. As you can see, we have a keypad. We have an Arduino to control all the components. We have a LCD screen to display what's on the keypad and also anything that's happening currently in the circuitry. And we have a door that's not in the picture, but we have it to keep all the items safe. The keypad connects to the Arduino, and the Arduino feeds into the LCD so that the keypad can be relayed to the LCD. This that you can see is a video of our LCD screen working with the keypad. And the flowchart on the right shows the process of what's happening inside the Arduino.
Something similar to our product is his laptop kiosks. These are mainly used by universities and are more strict by charging late fees as the laptop is not returned within 24 hours. Seeing how large it is, it tends to be more expensive and advanced as they have touchscreens. Our design is more tailored to high schools and are more compact to fit into the library environment, are breathable, and uses a pin number so students have an easier time with it. As for our next steps, we plan to make a full-scale product to be used in the school library. We also want to test with actual students so we can see how well it works. We would also want to alter our design to further accommodate different kinds of computers and the amount of loading time to extend past just our library.
Great, nicely done, librarians.
Hey team, great job solutioning for the problem. The last slide, which was again a little bit hard to catch, if you could just speak to the differences between the current student kiosks that are available and your design, and not just based on the bullets that you had in the slide, but kind of what makes it more suitable to use the version that you are creating.
So the kiosks that we found online, they're more tailored to universities, and they have much more far budget, while our school funds don't really accommodate that high of a budget. So we would be able to use our Arduino and the current kind of wood that we have, making it more affordable to our school and also to other schools in our district.
So is it just because of the material that you're using that will be more affordable, or are you doing something special in the design as well?
Well, our design is more simple as we just use a keypad, and the other universities use more like advanced technology, as in touch screens, which they cost more money, and which is why our design is more compact and it makes it more easier for students to use.
Have you wondered why the universities use that design? And how can it come into the schools as well if cost was out of the question?
We didn't really think about that yet, but that is a good thing to consider. It's just right now we just are still focusing on the high school aspect of things.
Okay, thank you.
Hi, team. It looks like you have the demo there with you. If that is it, do you want to show it off a little closer to the camera?
Yeah. The pieces aren't quite screwed in yet because it is still a cardboard prototype, but yeah, here's some of our products.
Very cool. Thank you.
It's going to be a bit bigger like when we actually like, make the final model of it, the full-scale prototype. But this is like kind of a rough design.
Yeah.
Good job, guys.
We have about another minute or so for the librarians' questions. Any feedback from our judges?
Yeah, I mean, great job, guys, on this product. Would love to kind of just learn a little bit more about maybe, um, like some of your learnings as you were creating this product iteration.
Yeah, I think we all learned a lot during this project. I specifically learned a lot about how to like work the Arduino. There were some things about that I didn't know, and I learned how to do those. Um,
So one of the main things that I learned while working on this project was a lot of the wiring that goes within this. So one of the main things that I learned was how to use a breadboard and an LCD monitor. So I thought that really helped my general understanding of our project.
Yeah, and I think a big thing we learned as a team as well is to work together because I think we had like a little separation with the CAD and the physical product at first. So we need to work together and learn to communicate better to get that all to kind of work together as one big product.
That's awesome. And I guess how was your experience as well with like, working with um, the main like client that you're trying to help and being able to iterate based off of their feedback?
I feel like working with Mr. Wilson was definitely very good. We had a lot of meetings with him to discuss our prototypes and also for him to give feedback about our product. One of the main things that he wanted was for it to be independent from himself because he wanted to save himself a lot of time. He has meetings with several staff and also sometimes teaches classes for other teachers when they're out. So he wanted to make sure that this could function without him having to physically be there.
Great. Thank you so much, the librarians. I find it always so interesting, especially seeing so many teams today having a similar or the same community partner and coming up with such different projects and these innovative ideas, hearing these challenges. So kudos to you all. We are coming up on our final team that is going to present tonight, and that is Team Clarity, an innovative solution to turbid pond water.
Hi, we are Team Clarity. We are a team of high school freshmen and sophomores based in Santa Clara, California.
Hi, I'm Hannah and I worked on digital and physical fabrication.
Hi, I'm Azalea. I worked on research and design.
I'm Swati. I do research and community outreach.
My name is Akil and I did sensors and code.
This is our community partner, Mrs. Mint. She currently works as the curator at the Peterson Middle School Nature Center, which means that she specializes in the upkeep and taking care of the center, as well as educating kids from around our school district on different science, biology, and the different biospheres that California experiences. And when we talked to her, we noticed that she had two main areas of need, which were invasive species, which are detrimental to the garden's native species. But when we looked into that, we realized that there were too many variables and it was too big of a problem for our scale and time constraints. So we switched to a second problem that she mentioned, which was the turbidity or the clearness of the lakes and knowing when to clean them, as it is an artificial pond with a filter that can be cleaned.
Our solution is an informational panel that educates local kids on turbidity. It's connected to a turbidity sensor placed in the pond, and there are LED light strips attached that flash different colors depending on the turbidity of the water. It also lets Miss Mint know when to change the pond's filter. Here is a quote from our community partner.
On this slide, you can see some of our early designs and prototypes. So on the left, we have a digital sketch, and in it you can see that we had small circular LED lights originally, but when we looked into that, we realized that they were too small and not bright enough, so we switched to an LED light strip, which would be bigger and brighter. Secondly, in the middle is a cardboard prototype. It's not to scale, but we made it just so we can understand how the different joints and everything fit together. And realizing that the roof was a weak joint led us to change it to just be one panel instead of two. And finally, on the right, we have a graph papered physical sketch with dimensions that also helped us know where to lay out the information and the different text.
Here are some samples of the text we will put on our educational panel. Some examples of what we will discuss are what is turbidity, what each turbidity level means, and how it affects each species in the pond.
One of our main components of our product is our turbidity sensor, which will be placed inside a pond and hooked up to an Arduino on our sign. On our sign, this will display LED lights, and it will indicate the level that the turbidity is currently at. So, for example, high levels of turbidity would show red. On our sign, we would include educational text, which teaches younger students about turbidity. We're also adding weather protection on our sign. So for the wood, we would add a sealant that protects it from the rain. And additionally, we're adding a roof that has asphalt shingles attached so that it protects the sign from any rain or other weather. And lastly, this will be placed in the amphibian restoration area, which is a little area in the nature center that is currently raising tadpoles to increase the population of frogs.
Here is a demo video of our product. We can see the LED turning green because the water is below an NTU level of 10. There are 4 LED colors corresponding with 4 different ranges of NTU levels. High levels of NTU can be harmful towards tadpoles and other animals living in the pond, such as the turtles and bluegill and bass fish. The design will help with the conservation efforts to increase amphibian populations along with utilizing these unique habitats.
Here's our product compared to 2 other products on the market. As you can see, the affordability and convenience is much better than the other 2. For the effectivity, we have not tested as much as we would like yet, so it is not included.
Some next steps that we would need to take is brainstorming alternative materials other than wood to improve its durability, because we found that wood is not always the best for outside projects as it often deteriorates over time due to weather and other factors. We are currently in the process of producing a 2-scale version of our product. We have all of the parts and components that we need. We just need to start assembling it and putting it together. And after this is done, we would test it and make improvements if necessary. We were also thinking of making the product interactive to engage the students and make it a better experience for them. And at the end, if we have more time, improve the affordability so that we make it more accessible. Thank you for listening.
Great job.
Excellent work, guys. I love your product. Uh, I work with sustainability products a lot. With the airlines, measuring the CO2s and other stuff. So whenever these kinds of projects come in front of it, I get goosebumps. So you did a good job in that. Your prototype is uh, approaching a MVP. You need to little bit work more hard on those stuff to ensure that it becomes a product which could be deployed. And I just wanted to ask you a question that what is the area which it will cover it if you wanted to deploy it in a small pond? So in a small pond, what would be the area it would cover and how many devices you need to put it? Will that be a single device and how many devices, suppose if it's a big pond? So do you have that dimensions or matrices based upon the research you have done?
One thing I want to mention, when we submitted this video, it was probably about a week and a half to 2 weeks ago, and we have worked on the project since. So we have added our information to the board. We haven't attached the roof or the pole to the back yet, because we will do that once we have more materials, as we did end up misplacing our roof when the classroom was cleaned. But this is what we have so far. So it's a little more than you were shown in the video. And then Akil, do you want to answer the question about the sensors?
All right. So yeah, ideally we would only need like one device because I think in the video it mentioned that it was connected to the signboard, but like we decided that we should just keep it portable. So ideally you just like hold it in your hand and you could put it in the lake and it would give you the correct level.
Okay. Is there any in the future are you also going to develop an app which can give some matrix data for future about the situation of the pond, or if there are any levels which are fluctuating, and if there is any uh, you know any actionable insights which could be drew out of those data, and then later some actions could be taken on that.
So we won't be creating an app, but what we will do is once the turbidity level is at like a rate where Miss Mint needs to clean the pond, we would send her a message to her phone. And like along with the level of turbidity that the pond is in, we may include like some things that could happen if she leaves it that way or doesn't clean it.
Oh wow, good. That's good.
Um,
Your
Sorry.
go ahead.
One more thing I wanted to add. Our signboard does have different information on how the different turbidity levels do affect the species that are found in the pond, such as frogs or small shrimp. So we do have information on the signboard about that.
Yeah, very good, very good. Your presentation is a CEO level presentation. I really loved it. Thank you. Good
Thank
job.
you.
I think I had a few of those questions which you answered already, but uh, just to follow up to understand a little bit better. So, when you say that the levels can be measured on a spectrum, like how bad or how good the turbidity is, based on each level that it's at, there will be a solution to it, right? Like if it's not that bad, then you can do something, and if it's very, very bad, then an action has to be taken by a partner. Um, I guess what I'm trying to ask is that is there like a real-time notification system or some sort of a feedback loop that your partner is going to always have known about the system, which can tell her how bad it's getting on a day-to-day basis, or if it is going to change over a period of time? Like do you have some sort of a timeline in mind for your product, or something that is going to help your partner know within a period of how bad it's getting and how to solve it through an urgent system of notification?
So we do have the LED light strip connected to the board, and depending on the levels that are in the pond, the light strip will change different colors. So if the pond is at a healthy level, it would be at a yellow or green light, but when it gets too high, it would switch to a red light, which is what we have so far. And in the future, we'd like to create an app, as Swati mentioned earlier, that would send real-time notifications to her phone. And the sensor is pretty fast at updating. I think it updates every hour-ish. So it does have real-time data.
Okay, sounds good. Thanks.
All right, we have time for one more question or comment. Any final thoughts from our judges? All right, it seems like we are good to go. Team Clarity, excellent job. And I just want to say, let's take a moment. Every single team that presented at this demo day, amazing job. So feel free to unmute. Let's give everybody a round of applause. Yeah, woo. No, personally, seeing these projects, hearing all about and the empathy and such beautiful thought and intention put behind this, you all give me hope for the future. So, without further ado, we're going to open up a breakout room, and that is where our judges are going to go. And they're going to have about 20 minutes. They're going to talk about all of your projects, your growth, your learning. And then they're going to come back and we will have an awards ceremony. Okay. So you might see that little breakout room pop up. Only judges go in there. All right. Awesome. So there we go. And what's really exciting is while our judges are deliberating, we have a wonderful keynote speaker. So I would like to introduce Tim Adcock, who's an engineer, technologist, and a consultant. So Tim, I'll let you take it away.
Okay. Can you hear me?
Sounds good.
It's fitting that we're talking about technology because I had a technology snafu here in the last 15 minutes. My Wi-Fi went down. I had to switch computers at the last second. So apologize for my background because I'm in a control room in my house, where's the only place I could get Wi-Fi. So technology takes us where it takes us, I guess. And so here we are today. So, okay. So what I wanted to spend a little bit of time talking about today is technology, and in particular, where technology has taken us and where we can go with it. What kind of things that we should really develop with that. So as a start, we can go to the first slide. Let's talk a little about this. So I wanted to start out a little bit about myself because I am a technologist. I love technology. I'm not afraid of technology. I always have the latest gadgetry. If you were to look around my room, I'm in a room that's got mixing boards and amplifiers and all kinds of tech equipment in here, and it's just an area that I feel comfortable. Um, but I'm I think there's lots of people here in this room that have lots of different interests, lots of different skill sets. And I think that's a really important thing because even though if we're doing projects that are related to STEM, everybody is welcome and everybody's skill sets fit into there. And that's kind of why I took 4 pictures and put them up here on this first slide because I have different aspects of interest and different aspects of my personality. I'm an engineer. I've worked for years on technology. I'm also a musician. I'm also a triathlete, and I also do improv and a little bit of stand up in my spare time. So try to do different kinds of things. And again, all those kind of skills and interests can become useful when you're working in an environment that normally might feel like something that only engineers or scientists fit into. But to go back for just a minute on the technology side of things, I listed a few things that I worked on in my past. I worked on airplanes. I put a picture of an airplane I worked on. Many people may have seen that. It's called the B-2, and I worked on um, cockpit instrumentation and avionics systems in that. I've also worked on speech processing for various aspects of technology there, where I've worked on some cell phone technology and some speech reproduction. I also spent a little bit of time doing DNA sequencing and building sequencers because I was involved in some cancer research. And, the mainstay of what I've done for most of my career has involved semiconductors, but other things like disk drives. And I've also did some work early on electric vehicles a long time ago before any of the cars that are out today. So really want to talk about is really what is technology. Can we go to the next slide? So I don't know what Webster says, but my view on technology is it's really any device or technique that solves the problem and hopefully improves the human condition and experience. And I put these on here because these are all very high tech products, or they were at some point, right? You may look at these and go, what the heck are these? I don't know what they all are, right? But early version of an airplane that the Wright brothers made. The thing with the wheel on the right of the airplane is what's called a pelvic hammer. My son's very interested in that, but that's something that goes back centuries. You turn it with a gear, and it could actually pound things. Many of you have maybe never seen a tape recorder. That's what's on the right, or a rotary telephone. And I doubt any of you have ever used a cassette tech, let alone a reel-to-reel tape player. So I wanted to show really what technology is, to show when we develop something that we think is high tech, and everything on here at one time was pretty high tech, probably the latest and greatest, does it last? What's going to happen to it? And what is our interaction going to be with it, right? And the question is, can we rely on technology? What is it trustworthy? If we put our trust in it, is it going to help us? Are we going to be able to use things for it? So we go to the next slide. So technology is something that people have made for a long time, and some of the things that are considered technology are things that you may not think of as technology. So on the bottom of this diagram is papyrus, right? So an ancient writing material that was designed, I think originally, the Romans get credit for this, but I think it was actually invented by the Egyptians, and along with hieroglyphs and many things of technology, scales and different kind of things, these were the highest tech things that you could have out there for the time. And those are things that are just super, super important for people who are living in a particular society. So we don't always think about that, but we really wanted to think about, what does technology do for us? Does technology advance our societies? Does it hinder our societies? And what are some of the things that we can look at that actually could be used to ease our type of living? So we can go to the next slide. So our inventors have been thinking about technology way beyond the time period that we have. These are a couple of sketches by Leonardo da Vinci. And you can see on the left, there's a flying machine, and on the right, there's a helicopter. So there's no way that he ever saw these kinds of things, but they were just roaming around in his head. And technology is something that people invent or discover all the time. It's out there, and there are things that are there that we can look at and understand and utilize. So it may not seem like something that is new or doesn't exist today, but in reality, the smallest little incremental things can make significant changes to the way our society is and the way things go. So go to the next slide, please. So if you look at some of those things, we like to think about, here are some of the technological advancements that have happened over time. This is a picture at the top of the Roman aqueducts. If you've ever been to Rome, and in particular, if you've ever been to Pompeii, you will be able to walk down a Roman street that's more than 2,000 years old. And the thing that struck me when I went there is that the Romans had running water in their homes. They didn't have a faucet that turned on, but they had a spigot that came on that went into a basin, and that water was in all the time. And many of these homes had water in it because the Romans developed technology to bring water into their cities and towns. And I showed a couple of examples on there. There's a water wheel that can be used, and those can be used to generate electricity. And the other thing is just a telescope, right? Telescopes have existed for many, many, many hundreds and hundreds of years because people were fascinated by looking up at the stars to see what else was out there. And if you think about that, what are some of the other things that have been invented or that we consider to be technology that maybe we hadn't really thought about? And one of the things I think about a lot is the light bulb. The light bulb is something that Thomas Edison took 800 attempts to create, and it made such a difference that people could actually extend their time into the night. Before light bulbs were invented and electricity was developed into people's homes and into buildings, people survived on candlelight or these small little lamps that were driven by some sort of a fuel, and it was very dim. And society basically shut down when nighttime came. So the application of technology to energy is something that's been very significant. And here's another area that harnessing the atom, right? We have been able to actually split the atom to create energy. And years ago, going back to the 60s and 70s, and even into some of the 80s, technology related to nuclear power from nuclear fission was very prevalent. A couple things happened in the late 70s and the early 80s with Chernobyl and something called 3 Mile Island, where we had meltdowns or partial meltdowns, that people became afraid of nuclear power. Now it's being discussed and explored again as a possible type of energy that if we can manage the radioactive components to it, it's very clean from an environment standpoint, doesn't billow smoke into the air, et cetera. Next slide, please. And one of the questions about technology is it useful? Is it always something that's good? Unfortunately, one of the main uses of technology in history has been for warfare. And some of those cases have been because people want to dominate a people or society around them, or they need to protect themselves from some society. So while technology can help societies, it can also create some divisions and create some warfare because people use the most advanced technology that they can in warfare because they want to be able to defeat their opponents. So that's something that's just there. If you look at all of human history, that's something there, whether it was the first sword or the person who had the first catapult to throw a rock or use a spear to kill an animal for food, whatever the case was. These are all things that have just been in existence. Next slide, please. And now there's a new technology that is out there on the horizon that is different than pretty much anything that we've had. We now have a technology and thus a tool that can mimic human thinking, learning, and decision making. These are all things that what you've heard of in terms of artificial intelligence have done. But the thing about it is artificial intelligence isn't new. In 2022, a company called OpenAI created a product called ChatGPT. And many people, I'm sure many of you have heard about this product and maybe even used it. And they created a product that could be put into the hands of everyday people to be able to use technology. But again, it's not new. If you go back in 1956, the term artificial intelligence was coined by a person named John McCarthy, and he had a Dartmouth conference that he had organized where scientists got together and talked about whether or not machines could learn and understand and adapt. And all the way back to 1950, a man named Alan Turing, who's typically thought of as the godfather of artificial intelligence, he published a paper called Can Machines Think? That really was very significant in terms of starting to think about this technology. So although we think it's new and it's become very prevalent out in society today, artificial intelligence has really been there for quite a while. And I wanted to talk a little bit about what this is, because as I said, artificial intelligence is something that mimics human thinking and decision making. And some people think, oh, artificial intelligence is better than real intelligence that we have. Well, let's talk about a little bit of that and see where this really comes from. Okay. So, yeah, go to the next slide. So, really, I wasn't going to give a biology lesson on this, but we're gonna start there because you have to think about what artificial intelligence is based on. And as I said, it mimics the brain, it mimics the nervous system. And the reality is, artificial intelligence was based upon the structures in our own human anatomy. There is something called a neuron, and a neuron is a element within our bodies that can transmit electrical or chemical signals back and forth. And so what happens is neurons actually connect to other neurons and they're able to transmit information. So our brain makes these connections and it builds these connections called synapses. And these synapses get used for us to transfer information throughout our brain or from our brain to muscles, to different tissues and different cells in the body. And so, AI, if it's done well and when it's emulating this, it starts to get to the point where humans, when they're looking at something that's artificial intelligence like we have today, many humans can't tell the difference between something that's real and something that's generated by an artificial intelligence machine. And that's, one of the things that we think about right today is that we see videos and are they real? And we see pictures and are they real? And we've gotten to the point where we don't know whether or not things are real or not because artificial intelligence has moved into the category where it can actually start to create things that we can't really tell the difference. And if you go back again, way back into the 1980s, there was a movie called The Terminator, which talked about how artificial intelligence had been created and basically became sentient and started to think in and of itself and basically took over the world. So if you've never seen Terminator, it's an Arnold Schwarzenegger movie. That's a very interesting movie to see. But even before that, if you go back into the late 70s, there's a movie called 2001: A Space Odyssey, where there was an artificial intelligence computer that controlled the ship that didn't want to be turned off and basically was stopping these astronauts in space from doing things. So science fiction has been out there and exploring these things for 30, 40, 50 years. And when the technology was first explored, and now we're in a point where we have actually products and things that can use artificial intelligence. So let's look at a little bit more at what artificial intelligence is. So we see what a neuron is, and that's a picture. But as I said, go to the next slide, please. There we go. What neurons actually do is they make connections. So they form a network in the brain. So one neuron creates a synapse to another. And one of the things that's very interesting about this is that you might learn a new task, or maybe you do a math problem, or you learn to speak a language, and you've created synapses in your brain that are used by your brain whenever you're doing that particular function. But the thing that's really masterful about your brain is that if something happens to other synapses in your brain, like if people get they get Alzheimer's or dementia, some of these synapses get blocked and can't be utilized anymore. Well, your brain actually can move and adapt and use synapses to do functions that those synapses weren't originally designed for. So I was reading on some of the research that's going on in Alzheimer's and dementia patients these days. And what they're saying is that if you learn, the more you learn all through your life, the more synapses you create and the less chance you have of getting dementia because your brain has all of these pathways to use. So artificial intelligence, the core aspect of artificial intelligence, uses this model of synapses. So go to the next slide, please. So on the left is something that's called a neural network. And a neural network is the basic building block of artificial intelligence. If you see, there's an input layer, and there's these things called hidden layers, and then there's an output layer. And when a neural network is learning, information comes into those inputs, and it takes one of those paths to get to an output when it's trying to find a decision. And one of the things that's really fascinating when I was studying neural networks was that we oftentimes don't know what path the neural network is going to take even today. And in many cases, when we're training a neural network, you may have heard of something called large data models, where we put lots of data through a neural network and we try to train it so it's accurate and comes out with the right answers that we want it to, is that these neural networks many times take actions that we don't know. And we don't understand why they're going down a particular path. And if you look at this, if you see the diagram on the left and you look at the brain neural connections on the right, they're very, very similar. Look at what those are, right? We've really tried to mimic the brain. And so the implementation that we have for these artificial intelligent machines are implementing these neural networks, and there's software on top of them, and there's modeling, and there's all kinds of things that are on there. And they have to be able to process things very, very fast. So you may have heard of companies that make very fast chips. So what's made neural networks really available today in large scale really came out of the graphics industry, from gaming. So there's a company called NVIDIA that was making graphics chips because people wanted to have faster and faster graphics for gaming. And they found that those chips could actually process the information in a neural network incredibly fast. And as a result, that technology is now used in these machines. And they're highly intensive in processing. They take a lot of energy because they're crunching and crunching numbers and then lots of software running. But those are the key things that are there. The neural network is really key to the process of what we have. So go to the next slide, please. So really, these neural networks machines are fascinating, right? The things that they can do today, right? They can write software for us. They can draw pictures. They can modify video. They can, although this has never happened, they can write a term paper or an essay for you, right? They can come out and do things for us because they're mimicking the same thing that goes on in our brain. But the truth is this: the human brain still is the ultimate supercomputer. As fast as these neural networks are today, they are not as fast as your brain. If you look at what's inside your brain, you have 80 to 100 billion neurons in your brain today. And each one of those neurons can form synapses, connections called synapses. Typically, each neuron can create from 1,000 to 10,000 synapses per neuron. And so and each one of these synapses carry electrical and chemical information back and forth, their messages back and forth, so that if you look at how much information your brain can process, there are over 100 trillion synapses in your brain today that you could utilize to do things. And if we really utilize our brain to the level that we're capable of, it's amazing what it is that we can do. Let's go to the next slide, please. So people ask, if you've got artificial intelligence, isn't it faster and better than our brains? The answer is no. Think of what your brain does when you're thinking something, and you might be walking at the same time. You can do multiple things at one time, and your brain can do those very quickly. You respond to stimulus that comes out, and you respond, and you can talk, and you can think, and you might be chewing gum at the same time when you're walking and doing whatever. And for me, I'm a musician, so I play drums, and so I can be doing all these different things at the same time. But those are things that we're trying to emulate and get as good as we can in these neural machines, but still, they're not as fast as your brain. And so technology that we saw it some of the historical things that we've had, and where we're going is that technology is both a tool to get things done, and it's also an output from our brain. We can create, we can discover, we can explore things and create technology. It isn't just out there creating itself. It's something that we're going to be involved in. And even when we use AI to help things, AI is not replacing your brain. Your brain's going to use AI. I was using artificial intelligence today to give me a summary of some physics things that I was helping someone with today. And again, we want to be able to use artificial intelligence. Let your brain use it. Don't let it replace your ability to learn. It's a tool. You want to use it. The other thing you have to do is artificial intelligence implementations are new. So don't just assume something from artificial intelligence is right. It makes plenty of mistakes. I was using an artificial intelligence tool the other day, and I asked it to give me the roster of a basketball team, and it was wrong. It gave me information of several players who were no longer on the team. And I told it so. I was using my voice input and said, "You've made a mistake. this is not the roster. This is an old roster. And it apologized to me and it tried to make corrections, but it couldn't get it. So I went and used a different AI tool, which I was using to search the internet with, and it gave me a correct answer. So some are accurate and some aren't. And they can be trained to give right answer. And you have to be careful because, as I showed you, the networks train information that go through them, and they can be trained incorrectly. And in those cases, it could give you dubious answers that aren't real. So the bottom line is AI's reasoning power today doesn't come close to the 100 trillion synapses connecting the 100 billion neurons in your brain. And the best technology that we can be developing today is inside your own head, and it's your own brain. Thank you.
Awesome. Thanks so much for sharing, Tim. I think thinking about technology, and I love how you called out that sometimes we forget the origins of technology and like we think of a lot of electronics, but technology has spanned so far and so long. And a lot of the teams today, they definitely are thinking about, how they can take what they want to develop, what they have created in their prototypes, and be able to utilize it for social good, which is really awesome.
Yeah.
So
society wants to be able to use that.
Absolutely. So I think we have like couple minutes left before the judges come back. Does anybody have any questions for Tim? Or Tim, if there's anything else you'd like to share, we really appreciate.
I'll wait and see if anyone has any questions. Don't be shy. Don't bite.
Yeah, you can put them into chat, or if you want to raise your little hand icon, we can do whichever.
Well, I think one of the questions I have is I'm curious how many people are using artificial intelligence today. Now I know we have kids that are in high school today, and there's probably some teachers that frown on that. I am a very strong proponent that you can utilize artificial intelligence along with your learning. It doesn't replace things. It can help you. And so hopefully our teachers will come to discover that it's not being used to, supplant what we're learning in our school, but it's something that could be a tool that we can utilize.
Yeah, absolutely. And I see that Alexis threw into the chat. Yeah, some of our teams, even during this event, utilize AI. So I feel like being mindful of it, seeing what its uses are, using it purposefully. But I also love that you called out like synapses, our brain, powerful, powerful.
Very, very much so. Don't forget that, right? You keep utilizing your brain. The movie, I didn't get to this, I don't think, but there was a movie with John Travolta called Phenomenon. If you can ever find this, it's really interesting because he plays a character who isn't a very really just kind of an ordinary, isn't super smart, and something happens to him. So his brain, he gets more utilization from his brain than anybody in the history of the world, and he becomes a genius, more than a genius. He's able to learn things and do things that no one else has been able to do. It's very, very, if you can find that movie, it's a very, very good movie. Very interesting to see what happens to him and how they happen. But it's all related to the fact that he's utilizing his entire brain, because we talk about the fact that we only use a small percentage of our brain most of the time, right?
Absolutely. Yeah. And you just think of all the opportunities. But yeah,
Right.
we are so grateful that you were able to join us during this event and hear a little bit more about technology and just the impact of it. And then also, we'll have to share some more of our team videos with you. You will be very impressed at the technology that these student teams have created.
Yeah, I'd love to see it. Like we talked about, I've been a judge and advisor on some of these things. Going really, I was thinking about this. It goes back for 4 or 5 years now that I've been involved in this organization in one way or another. So I've seen a lot of really great projects. I know the thing that I've always been impressed by your organization is that I do this at the college level as well, and I've seen students in high school create inventions and projects that are rivaling what I've seen college students do. So keep at it.
Yeah, and kudos again to all of our teams and the educators who are utilizing design thinking and invention to make that difference. So awesome. Thank you again so much, Tim. What's exciting is now we will have our award ceremony and our judges are coming back. But I'd love to go over what those awards are for everybody. Great. Awesome. So, as we said at the beginning of this event, you all should give yourselves a round of applause because you did such an amazing job throughout the entire project event experience. So I'm curious, really quickly, would any teams like to share just any final thoughts? What project event meant to them, the experience, anything you learned or grew? You can put it into chat. Well, you can reflect and think on it, and we would love to hear from you afterwards. Um, so let me just pull this up. Thank you. Back to our awards. So we really focus on these student mindsets, right? And the judges are going to award the teams based upon these mindsets. So we know that all of you might not want to go into STEM or entrepreneurship or whatever it may be for your next step of your journey, but we hope that you carry these mindsets with you on whatever pathway you go forward. So having ambition, agency, creative confidence, empathy, resilience, and curiosity. And each one of these is so integral for your growth, your development, and being that active member of the community. So today we are going to have 4 different types of awards, and they all go back to these 6 student mindsets. So our Need Finder Award is for a team that really listened to their user, you really connected with your community partner, involved them as an active stakeholder throughout the entire journey, and really brought that to the heart. Our Product Pivot Award is for a team that overcame many obstacles. You persevered, you learned, you grew. The Explorer Award is for a team that really prioritized learning. So being curious, maintaining that creative confidence as you developed new skill sets, you learned, and you continued to grow throughout the experience. And then finally, our Moonshot Award is for a team that had a notably novel or impactful idea. All right, so I think that our judges should be back. Awesome. So we're going to spotlight our judges to take over and announce our award winners.
Hi, everyone. So again, just reiterating, you guys all did a really phenomenal job. You guys should all really be proud at the efforts and, the outcomes that you've done. And it was great hearing all of you guys present and share your ideas with us. And so we're going to give your awards. Unfortunately, we could only choose one winner. And for the Explorer Award, that is going to go to Power Patrol. So congratulations. And our reasoning for that was we felt you guys did a really great job, just showing that you can take feedback and iterate with the client. You did a really great job of just considering all of, different designs and prioritizing it, but then also sharing with us the lessons that you learned. And so congratulations again. You guys did a really great job.
Congratulations.
So I can announce the next award winners. So for the next one, which is called the Need Finder Award, we were looking at and discussing all the teams who really went into the problem, understanding the problem first and not going in with the solution. Because sometimes, when we kind of go around a day and we have problems during a day, we think of the solutions first and the problems kind of disappear in the process. And so we wanted to really shine one of the teams which did a great job understanding their users deeper and going back to them to validate their idea because it's ultimately them who's going to use it. So for the Need Finder Award, the team that's going to win that is Wood Turner.
Congratulations.
Like I said, the reasoning is because I think for me, the highlight was the last video that you attached to your presentation, which is going back and speaking to your partner and your partner kind of giving you feedback and then you recording that and including that in the presentation. I think every team should remember to go back to their users and stakeholders and partners to kind of see how their idea is mapping out and if they'll actually be using that, or if they have feedback, get it back to your product and keep working on it.
Hey teams, everybody was amazing, very inspiring, very hopeful for us. And I'll tell you, there was heated debate in the judge room. So everybody, you just did fantastic. I'm going to present the Product Pivot Award. The Product Pivot Award recognizes a team that overcame obstacles, especially. So you tried, you failed, you tried again, but you kept at it. You pivoted. That's the Product Pivot Award. Everybody had some aspect of that, but the winner for that, who especially stood out, are the Mints. The Mints with the Ember Eye. You showed a lot of resilience. You showed that you can pivot, and you showed all these different iterations of your product, and you did great. So that goes to the Mints. Congratulations.
Congratulations, the Mints. And last but not least, our Moonshot Award.
Hello, guys. First of all, I would say that what Tony said, that we have a good discussion about who's gonna go with these awards, and it was a really one of the toughest 20 minutes of my life, I would say, to figure it out, those awards. You all have done a good job, and every team is a winner in their own aspect. Uh, don't be disheartened if you don't get it. Sometimes you don't get things, and then you work on it resiliently and improve them and make sure that the better version of that particular product comes up. So I myself has faced a lot of time in my product room where we go and try to build something, but when finally I bring it to the stakeholders or to the product strategy, they say, no, we didn't told you to build this one. It has to be that way. So again, we have to go back to the drawing room, work on the design and put up a lot of thinking process, the number of hours of development and coding, and then testing and deployment, and then come up with the final products and tell that this is the final product for that and get to the customer feedback sessions. So for the Moonshot Award, I would like to congratulate and give that award to Team Clarity. They have done a good job in bringing up the presentation very crisp and put up a lot of thinking process into that. Their creative confidence was very high, and I really like the presentation and the product. So congratulations for the Moonshot Award, Team Clarity. And again, I just wanted to add that whoever has not got, it's very close ties with multiple teams, and you know, um, you all are winners. So you go ahead and celebrate that you were able to participate in this particular event, and you will be participating in future events, and we'll see that how your design thinking, critical thinking comes up and emerges as a project team. So congratulations once again. Thank you so much for your all the products showcasing, and thank you so much to the project event team. Thank you.
Congratulations. I feel like I don't even need to close this event out. I feel like you just did a beautiful job and did it for me. Awesome. Yes. So to reiterate, congratulations to our award winners, but really congratulations to each and every team. I want to go back into these presentations and just show them to people because it really, truly is inspiring to see the dedication, the work, and all the effort that you all have done through Project Invent, and we know that you are going to continue to do wonderful things. So to our judges, thank you. To all the volunteers that have supported us along the way, thank you. To the Project Invent team, thank you. To our students, thank you. And to our educators, we know this could not happen without you. We see you, and we can't wait to continue to collaborate. So thank you so much, everybody, for coming to this demo day. And we'll talk to you soon. You should all be feeling really proud of yourselves.
Thank you. Bye-bye.
Hi, everybody. Congratulations. Have a good night. Bye, everybody. Thank you.